Okay. So give a brief introduction of yourself.
Mhm. My name is Akanksha Singh, and I'm from Mirzapur, Uttar Pradesh, and I did my graduation from IIT Lucknow in mechanical engineering, and currently I'm pursuing my master's from IIT Roorkee in water resources development and management. And my father is a farmer, and my mother is a homemaker. And my MTech thesis project is a sustainable wetland management using a machine learning and remote sensing approach. Um,
Okay. Okay, Akanksha, when did you complete your B.Tech?
I completed my B.Tech in 2020.
2020. And when did you start your master's?
In the year 2022.
22. So is it complete?
Uh, right now I'm in the second year.
Second year. So you will be leaving your MTech if you get this job?
Uh, 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 this one. Like my first priority is to get the job. So I can, or I can also convert in a part time because the coursework has done and my MTech thesis that I can do remotely also. So it is possible to convert the full time into part time along with your full time job. So it is also possible for me.
Okay. So, Akanksha, tell me what kind of products does HAL have, or what do you know about HAL?
Yes. Ma'am, HAL is the PSU. First thing, it is works in a manufacturing domain, and it is one of the uh, India's leader in a defense product. And the products, it includes in a manufacturing, research and development, and overhauling, repairing, and manufacturing of the spare part. This is the working zone of HAL, and its headquarters is located in Bangalore. And it is also worked with India's other organizations like for DRDO and ISRO.
Okay. When was it established?
It was established on 23rd December 1940.
By
Hmm.
by whom?
By Vaichal Hirachand.
Only him?
Ma'am, he was the major person that involved in the formation of
Okay. Okay. So why do you want to join HAL?
uh, Ma'am, HAL is one of the prestigious institutions that work in a defense domain. So working with him will provide me a great professional opportunities and also a good career growth with challenging opportunities. And working there, you can have exposure to work with a great mind. And till now, I have my academics. I don't have any industry level experience. So working with me provide me the industry level experience, hands-on experience, and and at different projects and working for a being the part of uh, the big PSU have also contribute in a nation building.
How do you think you're suitable for it?
Uh, Ma'am, the role that has the application that I've is a management trainee, and that require both have you should have a good technical knowledge as well as a manager skill. So, as far as the technical knowledge is concerned, I believe that I make a good justifications through my academics that can reflected in my CV. And as far as my management skills are considered, then I always been active participated in throughout my college events and everything. For example, currently I am a department placement representative in my department itself, and I also being the part of a coordinator team in the India's biggest test that has been organized by the IIT Roorkee itself. And in my graduation duration, I also part of a social club that used to provide a free education to the slum children. So that experience has made me to deal with the different kind of people, work in a team, and deal with the challenges, solve them. So I believe that all these things will equip me to work good with the HL, and I am sure that I'm able to contribute good to the organization.
So, can you tell me some experience where you face some challenging situation in your professional life? and how you handled it?
Uh, Ma'am, challenges, there are so many challenges that I face. But the one of the major challenges that I faced, like when I'm working with my final year B.Tech project, that was related to the four-legged crawler mechanism that was aimed to to make the mobility in a tough terrain. So there was a challenge that includes how to start this. So when we started working, we got a mechanism, theory mechanism, and where we work with different difficulties, like how to design and how to make it more optimized, and uh, so uh, that was a major challenge, but we have solved. But only a drawback of the project was we didn't get time to make it a prototype just because of COVID situation. So but we have solved so many problems today.
Okay, tell me a time when your team might have had some differences and how you resolved that.
Actually, ma'am, in my college duration, we have worked on a project like go-kart fabrication project. It was a go-kart design challenge where we have a task to design whole go-kart. So we have a team member of 20 people. We have our seniors also. We have our juniors. We are the juniors actually, and our seniors are working with. So there was a time that there were so many clashes between us because like so many miscommunications things happen. So many like what they have told, what we are not able to perform them. So that time we actually want to like discuss what the real problem is, and tell us clearly what are the reasons that we are facing, and then our seniors listens to them, and we are used to tell to them. So I think the communication was a major factor in all the process, and stating the fact and then solving as per the capacity. So I think, ma'am, we have like
Okay. So if you are given a job which is completely new to you, you don't know how to go about it and all. So how will you manage that?
no idea about the like what the task
Yeah.
that I was assigned to.
Yeah. You're given a task which is very new to you. You don't know anything about it. How would you go about doing that task?
Ma'am, my first approach is to like do a research. First thing, what is all about, what is the area, from find the materials that I can study about, and find for, and then I will try to study what thing that is related. What is my objective? First, I will clear out what is my objective. What are the things that I need to require in the process, and how can I get that? How can I get that from myself? How where I will try to contact people where I can take help from other people, and then I will try to solve that.
Okay. Over to you, sir.
Okay, Kansha, am I audible to you?
Yes, sir.
Okay, so basically you are going for HAL. Okay, so can you tell me about this stagnation property? Have you heard about it?
Sir, sorry, sir.
Stagnation
Stagnation.
properties. Yes, stagnation
Sir,
properties.
yes, sir. Stagnation properties are properties when a flowing fluid is completely stopped, like come to rest, or it does stagnation point. When a flowing fluid be completely, I flowing completely has been stopped, that is called stagnation
Hmm.
properties. Like for example, pressure. So
Hmm.
if we have flowing fluid stop, then pressure, like some of static pressure plus dynamic pressure, it's called stagnation pressure.
Okay, let us suppose you want to write a steady flow energy equation for a fluid flowing through a nozzle, and you just want to find out the stagnation pressure at the exit. How can you
It's
get that question?
okay, sir,
Yes, you can take your time.
sir, how to write like
Just assume that you have some adiabatic duct, you have any duct, and the fluid is flowing with some pressure and volume, or I can say with temperature. And I just want to calculate, I just want to find out the stagnation properties at the exit. Okay, let us say I just want to find out the stagnation enthalpy at the exit. And how can you write that?
sir, sir, we will use steady flow equation.
Hmm. It's just a simply an duct which is, let us say, insulated, perfectly insulated, and the fluid is flowing under adiabatically condition.
Yes, sir. Sir, I'm writing the. Sir, stagnation enthalpy will be equals to the enthalpy at exit plus like the velocity at the exit, v square by 2g, h2 plus v square by 2g.
Indicate फिर से क्या बोला आपने h1
Sir, stagnation enthalpy will be the enthalpy at exit plus to the velocity component v2 square by 2g.
enthalpy at the exit or enthalpy at the inlet?
Sir, enthalpy, sir, you asked the enthalpy at exit. How will going to tell you?
Okay, have you heard about critical pressure? What are the critical properties?
Yes, sir. Basically, in
Compressible
like
force.
during the phase transfer pressure, as we increases the pressure, like we first during which we increase the pressure, we have saturation region, and then first we have a liquid region, then saturation region, then superheated region. But as we keep increasing our pressure, there is a one point come where there is a no saturation there. It means that liquid is directly converted into superheated region, and that region is called a critical region.
Okay. Okay, I just want to know about the critical pressure.
Like
Okay,
sir,
suppose
value.
you have to design a nozzle. Okay, and the fluid which is flowing through the nozzle is compressible. Okay.
Reduce
First of all,
compressibility.
just tell me what will be the shape of that nozzle in that case. If the velocity at the exit of nozzle is above, let us say, 1000 meter per second, what will be the shape of the nozzle?
Velocity.
Design.
Yes, sir, velocity.
Have you understood my question? You
Sir,
just want to design the
sir,
nozzle.
your voice is little low.
I'm just saying you have to design a nozzle, okay, and at the exit of the nozzle the velocity is very much high, and let us suppose the velocity is around 1000 meter per second, and the fluid which is flowing through the nozzle is a compressible flow. Then what will be its shape?
Sir, since mass number in this case, as we calculate, is greater than 1, so the shape of nozzle will be converging.
Converging, sure.
Sorry, sir, diverging.
Diverging. So
Yes, sir.
according to you, the overall the shape of the nozzle will be going to be diverging. That's what
Yes,
you are
sir.
saying. Okay, so
Yes,
don't you
sir.
think at the end, when the velocity of the fluid is just is about to start from 0 to some value, in that case the diverging portion will going to decrease the velocity instead of increasing its value?
Sir, actually, sir, in case of compressible flow, sir, we have equation. I'm not able to recall the exact equations, but there is a two conditions. Like if there is a subsonic flow, then we have a converging nozzle. But if we have a supersonic flow here, what is velocity is 1000 meter per second, then the shape of nozzle is diverging. We can prove by area, but I'm not going to be.
Okay, so don't you think when the fluid is going to start flowing, just start going to flow from 0 to, let us say, from velocity of sound, till then the velocity the shape of the nozzle should be converging type, because in that case the
Yes, sir.
velocity is going to be increased continuously.
Yes, sir. We can have converging, then we can have diverging.
Okay. Okay, so what is the value of the pressure at the minimum cross sectional area?
So what is
What is
the
the pressure
pressure?
at the minimum cross sectional area of the nozzle?
Sir, I'm not sure about exact pressure value, but that pressure should be greater than the vapor pressure of a liquid that is flowing to avoid cavitation.
Okay. Okay, you just said cavitation. What is the meaning of cavitation? How do you define the
Sir,
cavitation?
sir, basically what is happening is that when the liquid evaporates, then there is a vapor above it, and that vapor applies the pressure of the liquid surface. But what is happening when pressure is when that where is liquid, there is atmospheric pressure above it in general cases. But in normal, like during the flow inside somewhere, when the pressure above it is below that atmospheric pressure, the liquid already start evaporating, and that leads to the creation of air bubbles. And this is phenomenon called cavitation. And when liquids flow with the airspace, and when there is sudden rise in pressure in the next season, it bursts out, and these need to be like a surface damage of the medium that around its flow. It is called cavitation.
Okay. Okay. Also, okay. Have you heard about critical radius?
Yes, sir.
What is the meaning of that?
Sir, critical radius we generally study in a heat transfer. Basically, what is happening, like when you have a cylindrical object or a spherical object, when we start insulating, there is a two things, like conductance resistance is increasing and convective resistance is decreasing. So there is a one point we have a maximum heat transfer and minimum resistance. So the radius at which we have a maximum heat transfer, that is called the critical radius of insulation.
Okay. So, what do you think the thickness of the wire which we use normally over the which we normally used is more than critical radius, or is it less than the critical radius?
Sir, in the wire, we have a electricity flow due to which heats are generated. So our purpose is like we have to increase the heat transfer because heat accumulation is not good for the wire. So so we have to keep our thickness of radius insulation at critical thickness or below that, because if we keep more than that, there is a like heat transfer will be less. So for the wire insulation purpose, we keep that at a critical or less than that.
Okay. Okay. What is the meaning of lumped heat analysis? What does it say to?
Sir, lump heat analysis is basically a transit heat analysis where we consider a body that having the least resistance to heat flow. And basically, the body that has uniform temperature throughout, it is unsteady state because at second moment the whole temperature of the body may be changed, but at a particular point of time, every part of the body have the same temperature. So that is called lump system.
Okay. Now suppose you have a spherical body. Okay, I'm just
So,
assuming that the bio number of this body is less than 0.1. In that case, how the temperature is going to be vary from the center to the surface?
sir, since in the
What variation
lump
will you observe?
body,
Mhm.
in the lump system, we have a least resistance. So we have a like if resistance is low, then heat will be conducted very smoothly. So the temperature profile will be like more or less straight will be, because there is not much temperature drop at the center to the periphery of the body.
Okay, and what about the surface? What about the temperature variation from the surface to the uh, surrounding temperature?
Sir, the surface to surrounding temperature.
From the surface to the room temperature. What will be its
Sir,
variation?
the temperature, because if we consider that the temperature of the surface is greater than the surrounding temperature, then there will be a like variation, like this type of variation. Yeah.
Can you name this? Can you name the variation of this curve?
So in the type of graph,
Do you remember the equation or the temperature distribution?
equations like temperature distribution of no sir, I'm not able to call the temperature distribution equation between the outside sample.
Okay. Okay. What is the importance of thermal diffusivity and the kinematic viscosity? What is the physical significance between these two terms?
Thermal diffusivity and kinematic diffusivity.
What is the difference between these two
Uh,
terms? And what are their physical
the
features?
thermal diffusivity we use in the case of heat transfer. Kinematic distribution, diffusivity we use to like in case of fluid phenomena. And in both cases, we are basically used in a boundary layer conditions. Basically, the ratio of two define the growth of the boundary layer. Like if which will dominate, if a hot fluid is flowing over the plate, then the how these both values will define how which profile will dominate, like thermal boundary will dominate or a fluid boundary will dominate. And physically, the thermal diffusion signifies the rate of diffusion of heat transfer. Like it is a ratio of the thermal conductivity upon the rho Cp, like amount of heat stored in a body to the amount of heat that is conducted to the body. And similarly, the kinematic diffusibility is a ratio of the viscosity upon dynamic viscosity upon the density.
Okay, Vansha, let me give you feedback regarding the same interview. अभी आपको जो टेक्निकल की जो नॉलेज थी हाँ वो काफ़ी अच्छी है, ऐसा कुछ इशू नहीं है, ठीक है। हाँ बस थोड़ा सा कंप्रेसिबल फ्लो पे थोड़ा ध्यान देना। कंप्रेसिबल फ्लो में आपने गलत आंसर दिया, ठीक है ना। जैसे मैंने आपसे पूछा था नोजल की शेप कैसी होगी, तो आपको पता होना चाहिए कंप्रेसिबल फ्लो के केस में जो नोजल की शेप होती है कंप्रेसिव कन्वर्जिंग डाइवर्जिंग टाइप की आपके पास होती है। यहाँ पे बैक नंबर 1 आ रहा है, वहाँ पे जो भी प्रॉपर्टीज आपको जो मिलती है क्रिटिकल प्रॉपर्टीज आप कह रहे हो, चाहे वो क्रिटिकल प्रेशर की, मैं वहाँ पे आपसे क्रिटिकल प्रेशर इसकी मैं बात कर रहा था, लेकिन आपको थर्मोडायनामिक सिस्टम की बात कर रहा हूँ, ठीक है। उसको कंप्रेसिबल फ्लो को थोड़ा सा एक बार रिवाइज करना, उस पर रिवीजन की आपको रिक्वायरमेंट है। और लास्ट में आपसे जो मैंने पूछा था ये काइनेमेटिक विस्कोसिटी और थर्मल डिफ्यूजिविटी के बीच में डिफरेंस, तो यहाँ पे क्लियर होना चाहिए कि जो दोनों के दोनों इनका एक बहुत ही इंपॉर्टेंट फिजिकल सिग्निफिकेंस है, ठीक है। दोनों ही बाउंड्री लेयर्स में आप देखते हो मोमेंटम थर्मल डिफ्यूजिविटी क्या रिप्रेजेंट कर रही है कि हीट डिफ्यूजन रेट क्या है आपके पास अमंग द अक्रॉस द लेयर्स, और जो काइनेमेटिक विस्कोसिटी है वो फिजिकली आपको क्या रिप्रेजेंट कर रहा है, वो आपको रिप्रेजेंट कर रहा है मोमेंटम डिफ्यूजन रेट। Okay, on the basis of these two terms, you are going to compare the thermal boundary layer and hydrodynamic boundary layer। तो आपको इसका क्लियर होना चाहिए कि क्या है, इतना वो फॉर्मूलाज या फिर आप कौन से सब्जेक्ट में पढ़ते हो इसमें घुसने की रिक्वायरमेंट आपको नहीं है, ठीक है ना। इसका ध्यान रखना। ओवर टू यू मैम।
Thank you, sir. Okay, Akanksha. First, let us discuss about your introduction part. Like in introduction, you don't have to like mention about your father, mother, or personal details. Okay. And moreover, you could have mentioned your MTech project. You could have mentioned later on. You told me you participated in events and all, and you have been leading the events also. So you could have mentioned your skills over there in your introduction. Okay, fine. Then secondly, coming to HAL, okay, your knowledge was good, so that was okay. But even then, about you should study about some competitors and which is the biggest, some common questions like this. Okay. Then let's come to the situational questions. Okay, so let's come to why HAL first. Why HAL was okay. You told me why do you want to join that and what kind of company HAL is. That was okay, fine. Um, but how you are suitable, okay. You don't have to say many stories, kind of things. Okay, make it a bit short. Okay, fine. And then coming to situational questions were also okay, the way you approached it. Like when I told you something new is there, obviously research work is there. You will research, but then later on what you will do, you have to design those steps in your mind. Okay, first. Okay, so research is the first point. Second is how will you go about it. Okay, so how means you will ask your seniors, or you will recognize the teams which are involved in it, and you will contact those teams. Okay, something like this. Okay, fine. So you have to design some steps on that. Rest was okay, fine. Okay. Okay.